So we have question 4. It says, using the diagram above and without the use of a calculator, determine the value of 4.1.1 sine theta and 4.1.2 sine theta times cos theta, right? So how do we go about answering this one? So obviously we can see that we are given a diagram there. So this is how you'll find your question. Then the first thing that we want to check here is check what we are given. We are given the hypotenuse side and the adjacent, but we are not given the opposite side. So what we should do here is to construct the opposite side. So this becomes a right angle triangle. Now that we have a right angle triangle, we can indicate this is y here and then try to solve for this opposite side. So how are we going to solve for the missing side here? Because this is a right angle triangle, we can use the Pythagoras theorem. Now our r is the hypotenuse, so we substitute 2, and the x is the adjacent side. We substitute our root 3 and then square plus y square. Now if we solve this, this is 4, and then here this is 3 plus y squared. Now to solve for y, we take this 3, transpose it to that other side. That's 4 minus 3, and then is equals to y squared. Then we have y is equals to y squared. Then solving for y here, we can just put a square root both sides, and then this is y is equals to 1, right? So y is equals to 1. Now we can plug it in here. This is our y. It is equals to 1. Now let's go to the question. What does it want? It says determine the value of sine theta, right? Now looking at sine theta, we know using our SOHCAHTOA, sine theta is opposite of a hypotenuse, cos is adjacent of a hypotenuse, and tan opposite of a adjacent. So looking for sine theta, that means here we'll have sine theta is equals to opposite over hypotenuse. Our opposite side is 1 and our hypotenuse side is 2. So that means the value of sine theta is equals to 1 over 2. Now, okay, for 4.1.2, now we are required to determine the value of sine theta times cos theta. So you will remember from the previous question that we have 1 here, which is our y, and then looking for sine theta, looking for the value of sine theta cos theta. The sine theta we've already calculated, that's opposite of a hypotenuse, which is 1 over 2. But what is cos? Cos is adjacent of a hypotenuse. This is our adjacent and this is our hypotenuse. So here we have root 3 over 2. Now multiplying this, if you say 1 times root 3, that gives you root 3. If you say 2 times 2, that gives you 4. So you can see that I'm solving this without the use of a calculator. So this is what you are expected to do. So we have 4.2. It says if x is equals to 60 degrees and y is equals to 45 degrees, determine the value of the following without the use of a calculator, right? So what do we have there? We are given that x is equals to 60 degrees and y is equals to 45 degrees. And the question that we have goes as half sine 2y minus 2 tan squared x over 2, then close bracket cos x, right? Now we have to come here. Where I see y, I substitute 45, and where I see x, I will have to substitute 60, right? So I have half sine and then 2, y is 45 degrees, and then here I have 2 tan square, and then x is 60 degrees over 2, close the bracket, then cos, again x is 60 degrees, right? Now having to solve this, I have 1 over 2, then 2 times 45 degrees is sine 90 degrees, then minus, this is 2 tan squared, 60 divided by 2, that's 30 degrees, and then cos 60 like that. At this point, let's now start using our special angles to solve this. Now we know sine 90 degrees is equals to 1. This is 1. And then minus 2. Now what is tan 30 degrees? If we check here, where is tan 30? This is tan 30 is equal to 1 over root 3. So we substitute 1 over root 3 and then we say square, right? Because that's tan squared 30. And then what is cos 60 degrees? Let's go to cos 60. This is cos 60 is equals to 1 over 2, right? Now 1 over 2 times 1 is 1 over 2. And then solving inside here, we have 2. And then if we solve this, this will land us with 1 over positive 3, right? Because root 3 times root 3 will be positive 3. Then close here, we have 1 over 2. Now multiplying here, we have 1 over 2. Then multiplying everything inside here, that's 2 times 1, which is 2 over 3. And then multiply that by 1 over 2. So this should give us 1 over 2 minus 2 times 1 is 2. And then 3 times 2 is 6, right? So having to solve this, what are we going to have? So we'll end up with 1 over 2. If we simplify this one, that's minus 1 over 3. So 1 over 2 minus 1 over 3, this should give us 1 over 6. Now 4.3 says determine the acute angle B to 2 decimal places. So we are given sine beta minus 17.8 degrees is equal to 0.215. What are we supposed to do here? The point here is we want to isolate this B here. So we want this B to be left alone here in the left hand side. So what do? We take this trig ratio, transpose it to this other side. But whenever we transpose a trig ratio, this is what happens, right? It becomes an inverse like this. So this is sine arc, and then this is 0.215. So inverse of sine 0.215. Then this is B minus 17.8 degrees. And then if you punch all this in your calculator, because remember when it says round off to 2 decimal places, that means you can now use a calculator. So you punch all that in your calculator, that's 12.42 degrees. Then what are you supposed to do? Take this one, transpose it to the other side. So your beta is equals to 12.42 degrees plus 17.8 degrees. Then your beta is equals to 30.22 degrees, right? 4.3.2, we are given tan 3 beta is equals to root 3. So what do we do if it is like this? This is tan 3 beta is equals to root 3. So whenever you have something like this, again, you leave off this angle here and then you transpose the trig ratio. So you'll only be left with 3 beta here, and then take this tan to that other side, and then that becomes inverse of tan and then root 3. This is 3 beta. When you punch all this in your calculator, it will give you 60 degrees, right? Then divide by 3 both sides, divide by 3, your beta should be equals to 20 degrees. 4.3.3, we are given 3 sine beta over 2 is equals to 2.0125. So how do we tackle this one? We have 3 sine beta over 2, and then is equals to 2.012. So remember, the goal here is to isolate the B, the angle beta. So now what are we supposed to do? We have to get rid of this coefficient here. But how do we get rid of this coefficient here? We can divide both sides by 3, or we can apply our reciprocal, whereby we'll multiply both sides by 1 over 3. Right, so we multiply by the reciprocal of this coefficient here. So 1 over 3 times 3 will cancel off this 3. So now we are only left with sine beta over 2. So you don't do this, you don't cross multiply with this 2, because this here is the angle, right? So if you multiply 2.0112 times 1 over 3, the solution that you get is 0.67 0.0667. Right, so at this point you should avoid having to round off because you haven't arrived at the final answer. So this is b over 2. At this point, what do? Again, you don't cross multiply here. You take this sign here and then you transpose it to the other side. Now it becomes inverse sign, and then you put that whole decimal there, 667, and then there you go. So it gives you b over 2, and then if you punch all this in your calculator, that should give you something like 42.1185, and all those numbers. So don't round off as yet. At this point, you can just cross multiply, and then this is b is equals to 2 times this, and then since this will be the final answer, you can then round off to 2 decimal places, 84.24 degrees. Right. Now 4.4 says determine the value of the expression without using a calculator. So what are we given there? 5 degrees. So we want to make use of this table here of special angles. Then looking at tan 30 degrees here, let's check. This is tan 30 degrees, and bear in mind that this will not appear in your formula sheet, so you'll have to know this table, right? You'll have to find a way to memorize this table so that you know all the values here. Then this is tan 30 degrees. Tan 30 degrees gives us 1 over root 3. And then cosec 60 degrees. We don't see cosec here, but then we know cosec is an inverse of sine. So you just count here 1, 2, 3, and then you know that cosec theta is an inverse of sine theta. So what does this mean? It means that when we're looking for cosec 60, we just have to go and look for sine 60 here, right? So we want cosec 60, but then looking at sine 60, it's root 3 over 2. Since we say that cosec is an inverse of sine, we want to try and write this in an inverse way. So how do we write that in an inverse? We take this denominator, make it a numerator, and the numerator we make it a denominator. So how are we going to express cosec 60? We want to say 2 over root 3. As simple as that. Then over cot 45 degrees. Now if we count here, we have 1, 2, 3. We see t. That means cot theta is an inverse of tan, right? So cot is an inverse of tan. So in other words, I'm going to go to tan 45 and then try to express this in an inverse. So we know 1 over 1 is the same as 1. Then having to inverse this, it will still be 1 over 1. So cot 45 degrees is still 1. Then let's check here. Multiply by sine squared 45 degrees, right? So having sine 45 degrees, that's 1 over root 2. So we're just going to substitute it as it is, 1 over root 2. But then don't forget we have the square here. So we have to say square. Now from this point, it's just a point of multiplying. This is 1 times 2, it gives us 2, and then root 3 times root 3, that gives us 3. And then remember, over here means divide, and then we can just have this. This is 1 times 1 squared, it's 1. So we still have this 1 here, and then root 2 square is equals to 2. So 1 times 1 over 2, that's 1 over 2, right? So having to deal with this, if we do our reciprocal here, try to change this divide into multiply, we'll say multiply. But then what are we supposed to do with this number after we change the sign? We have to also reciprocate the number. So the denominator becomes numerator, and numerator becomes denominator. So 2 times 2, that gives us 4, and then 3 times 1, that gives us 3. So our solution for all of this is equals to 4 over 3.